Mr. Hassan's Maths channel. I'm now answering a question from, it's actually from one of my notes pages. It's Test Your Understanding, and I think it's taken from a textbook, and I can't remember which textbook I took it from. But anyway, here we have a circle, okay, which has got the equation x squared plus y squared equals 25. And we have this little area enclosed between the circle and the line x equals 4. Okay, we want to find the volume obtained when the shaded region is rotated 360 degrees about the y-axis. About the y-axis. So we know when something is rotated about the y-axis, okay, then basically you have the formula would be the volume is equal to pi times x squared dy. Pi times x squared dy. Okay, if it's about the y-axis, you're going to have x squared dy. If it's about the x-axis, you'll have y squared dx. And the reason being is, like, if you want to rotate something around the y-axis, let's just imagine for a minute that we're just rotating, you know, a little part of it. Okay, like for example, this section here. Okay, just imagine we're rotating this section here about the y-axis. When you rotate this section about the y-axis, the whole of this section here, then basically it makes like a cylindrical shape. Okay, it makes like a cylindrical shape, right? And the volume of the solid that's formed is the volume of the cylinder. This is the radius of the cylinder. Now we know the volume of a cylinder is pi r squared h. So here, this is the x coordinate of that point. Okay, so it's going to be, that's the radius. The radius is equal to x. And the height of the cylinder is that small little tiny bit there, which is basically, you can call it a small amount in the y-axis, a small little amount in the y-axis, the y direction. So the volume would be pi times x squared dy. Okay, that's where that comes from. When it's rotated around the x-axis, then what happens is you end up with basically, you know, the radius is now the y coordinate and the thickness is now the x coordinate. So it's going to be pi y squared dx. All right, so now that's the formula in general. Now we also learned that when you have the formula for the volume of the area between two like functions, okay, rotated around the x-axis, then it becomes kind of like this type of, like a tire type of shape. Right, so you have like the inner radius and you have the outer radius. Okay, and you know, it's like the volume of this kind of, you know, tire type of shape. So the volume of the, you know, this part that we want, which is going to be, if you imagine this being rotated around, it's going to make like this tire type of shape around. It'll have a certain thickness. Okay, I haven't drawn it so well, but anyway, that basically the volume of that kind of little disc all the way around, okay, is going to be the volume of the whole thing minus the volume of the inner disc. So it's given by the formula pi, and in this case you have the outer, let's call it the outer one x1, okay, dy. That's like the volume of, let's call it this, pi x squared dy minus x1 squared dy minus, that's like the volume of the whole thing minus the volume of the part that's missing. And if we call this, if this is x1 and then the inner one was x2, there will be pi times x2 squared dy. Okay, now these can be combined together as pi times x1 squared minus x2 squared dy, just taking out pi as common and just integrating it as 1. Right, so this is a nice little formula when you have two, you know, like two functions. You want to find the volume between the area between them when it's rounded, when it's, you know, wrapped around either of the axes. In this case, we're going to have it in this form here. So I'm going to just keep that formula just to make it clear. So this formula here is what we need, right? So in this case, we have x squared plus y squared equals 25, and we have x equals 4. Now x equals 4 is like our x2, and this is like our x1, okay? because it's the one on the outside the circle. So we can say x1 squared is equal to 25 minus y squared, and x2 is equal to 4. So what we can do here is we can say that the volume is going to be pi times, we're going to have 25 minus y squared minus 4 squared. Okay, so this is 25 minus y squared, because this x1 squared is 25 minus y squared. So all of this is the same as that. This is actually equal to this, okay, minus x2 squared, which is basically 4 squared, which is going to give you 16. And that has to be integrated with respect to y. And we need to know the limits. Now the limits here, let me just get rid of this now to make it a bit clearer. The limits here are going to be these points where the line and the curve intersect. Okay, so you're going to have this point here and this point here. Okay, these are going to be our two limits. So you're going to have our, let's call this B and A. This is going to be B, this is going to be A. And those are our limits that we need to have here, B and A. Okay, so how do we find those limits? Well, it's where these two intersect. Where do they intersect? How do you find where they intersect? You have x squared plus y squared equals 25 and x equals 4. We can use substitution, replace the x with 4. You have 4 squared plus y squared equals 25. So y squared is equal to 25 minus 16. So y squared equals 9, which means y is equal to plus or minus 3. Plus or minus 3. 3. Square root of 9 is 3. So this is going to be plus 3, of course, and this is going to be negative 3. So now we can have our integral ready exactly as we need it to start integrating. We got between minus 3 and plus 3. 25 minus 16 is 9. So you have 9 minus y squared. We have to integrate that with respect to y. So if you integrate with respect to y, once we start integrating, we get rid of the integral sign. 9 integrated with respect to y becomes 9y. And minus y squared integrated with respect to y becomes minus y cubed over 3. And we have our limits between 3 and negative 3. So you have pi, and we're going to have 9 times 3 minus 3 cubed over 3 minus, and then we're going to put minus 3 in here. So 9 times negative 3 minus negative 3 cubed over 3. And don't forget the pi always. So now we can say that this is equal to, this is pi times 9 times 3 is 27 minus, this is going to be 3 squared. That's going to be 9 minus, and here you're going to have 9 times minus 3, which is negative 27. And here you're going to have minus, and minus gives you plus. Okay, because you have minus, there's going to be minus 27 over 3, which is 9. So minus and minus is plus. So you have plus 9. So we can see from this, we're going to get pi times 27 minus 9 is 18. Minus, and minus 27 minus 9 plus 9 is negative 18. Okay. So we end up with 18 plus 18, which is 36. So 36 pi cubic units. Cubic units. So there we have the answer to the question. All right, for question number 2, about the volume between two curves around the y-axis. Okay, so this equation nicely becomes in terms of y squared. In terms of y squared, 25 minus, in terms of x squared, sorry, becomes 25 minus y squared. It makes it easy. And that is the solution to our problem. Okay, so hopefully that is clear. Now, other questions that you might want to watch from the Test Your Understandings of this chapter, I've placed a playlist here for the Test Your Understandings from this chapter. Other questions you want to learn about volumes of between curves, you can find in the playlist over here. The playlist and volumes in general, you can find from P1, you can find over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.